We will continue our discussion of section 6.5, looking at our inverse trigonometric functions. We're going to begin with an example that involves evaluating a composition of trigonometric functions. Our first example asks us to find the tangent of the sine inverse of negative 4 over 5. So we're going to begin by looking specifically at the part of the problem that lies inside the parentheses. So we're going to focus for a few minutes just on this part. Now we know that by definition what this is asking me to do is to find an angle that when I take the sine of that angle, I get negative 4 over 5. Now one of two things can happen with a problem like this. One is that the negative 4 over 5 is a value that I'm familiar with, and I can name the angle very specifically. Like I could say that the angle is pi over 3 or pi over 6. But that is not the case here. Negative 4 over 5 is not an exact value that I'm familiar with from my unit circle. So in this case, the best thing that I'm going to be able to do is to draw a triangle to represent that angle. So I'm going to approach it from that direction. And the thing that I need to do is to decide where I'm going to place that triangle. And the quadrant that the triangle is going to go in hinges on the definition for the inverse sine. So if you remember, when we defined the inverse sine, we said that the angle had to be in quadrant 1 or quadrant 4. And recall that they gave us two options for the angle, one to deal with the positives and one to deal with the negatives. And so since this is a negative 4 over 5, then that tells me that my angle needs to be in quadrant 4. So I'm going to draw an angle in quadrant 4. I'm going to place it in standard position, so it's going to go along the positive x-axis, and then the actual angle is going to lie in the fourth quadrant. Remember that we're rotating either up for a quadrant 1 or down for a quadrant 4, so we're going to have our angle lying right here. Now, what I'm going to do is I'm going to make a triangle out of this angle. So I'm going to use the initial side and the terminal side, and I'm going to connect them with a line to make a right triangle. Now, what do I know about the sides of that right triangle? I know that the opposite side is negative 4, or 4 actually, and the hypotenuse is 5. Remember your definition for sine for your SOHCAHTOA. Sine is opposite over hypotenuse. So we know that the opposite side, which is over here, is going to be 4, and the hypotenuse of the triangle will be 5. Now we are going to place that negative, but what you want to remember is that the negative is free to float either with the 4 or with the 5, depending on the problem. However, we never see a negative on the hypotenuse of the triangle. So the negative is either going to land on this leg or this leg. So let's see where it's going to go. We're going to go in a positive direction here. So this one would be positive, but as we drop down, we'll incur a negative value. All right, so the negative is going to go on the 4. The 5 will remain positive because it's the hypotenuse. Now, in order to find the missing side, we can use Pythagorean theorem. So I'm going to set that up and find that missing side. So I will have, let's call this side A. So I'm going to have A squared plus my other leg squared, which would be negative 4 squared, is equal to the hypotenuse, which is 5 squared. So we have A squared plus 16 is equal to 25. Subtracting 16 from both sides will give me A squared is equal to 9. And then taking the square root of both sides, we have A is equal to 3. So I can go ahead and label this side as 3. Now again, it's going to be positive because we're moving in a positive direction. All right, so what we have done now is we have basically solved the part of the problem that I've circled over here. Now, granted, I have not solved it specifically because I couldn't do that. I couldn't come up with a specific angle that would be the answer to that. However, what I have done is draw a picture, and now I've said that the answer to this is represented by this picture for theta. So once that's done, let's go ahead and bring our tangent down. And let's finish evaluating our problem. So now we need to find the tangent of angle theta. And again, angle theta is represented in the picture. And so we need to remember that for our definition for tangent, that is going to be the opposite over the adjacent. So we'll look to our triangle, and the opposite side is going to be -4, and the adjacent side will be 3. And so the answer to part A of our problem will be -4 over 3. Okay, so let's go ahead. I'm going to erase this, and let's go ahead and look at part B of this same problem. Now, part B is going to work in an almost identical manner. We're finding the cosine of the arctan, which remember is the same thing as the tangent inverse, of 0.4. All right, so again, I'm going to start by looking specifically at this. Remember that this is asking me to find an angle that has a tangent value of 0.4. Now, what I'm going to do is I'm going to go ahead and write 0.4 as a fraction. All right, so it's 4/10. So I'm going to write it as 4 over 10. And then I'm going to reduce it. So I need an angle that has a tangent value of 2 over 5. Now, again, either this is something that I know has an exact value, like pi over 3 or pi over 4, or it's something I'm going to need to draw a triangle for. And 2/5 is not a value that I recognize from my unit circle. And so I'm going to go ahead and draw the triangle to fit this problem. Now again, the issue becomes, where am I going to put the angle? So I go back to my definition for inverse tangent, and I see that I can use quadrant 1 or quadrant 4. Remember, quadrant 1 holds the positives and quadrant 4 holds the negatives. So since our value is positive, we're going to be in quadrant 1. So I'm going to go ahead and draw my angle, again placing it in standard position and putting it in quadrant 1. Our theta value is going to sit right here, and we're going to drop a line down to make a triangle. Okay, what do we know about the sides of the triangle? We know that the opposite side is 2 and the adjacent side is 5. So opposite is 2, and it's positive because we're moving up with that. And the adjacent is 5, also positive because we're moving to the right. All right, we can use Pythagorean theorem to find our missing side. So let's do that very quickly. We would have 5 squared plus 2 squared is equal to the hypotenuse, which we'll call c squared. 5 squared is 25, 2 squared is 4. So adding those two together, we have 29 is equal to c squared. So c is going to equal the square root of 29. And we'll plug that in on our picture. Now, again, what we have done is we have found an answer to the part that I circled in the problem. It is not an exact answer like an exact angle, but it is an angle. It's angle theta. So let's go ahead and bring now the cosine down beside it, and let's finish up the problem. So I need to find the cosine of the angle that's represented in the picture. Remember that cosine, by definition, is adjacent over hypotenuse. So the adjacent side is 5, and the hypotenuse is square root of 29. We'll rationalize that final answer, multiplying top and bottom by square root of 29, giving me 5 on the square root of 29 over 29. Okay, we're going to look at a couple of other examples, some applications that use this same idea. Okay, so our next example asks us to find a situation where a lighthouse is to be constructed half a mile from a long straight reef as shown. All right, so we want to construct a lighthouse from the reef. We know that in order to ensure the light illuminates certain portions of the reef, the engineer needs a formula for theta in terms of x. And so they've been very nice to us with this problem in that they've given us a picture, which a picture always makes things very easy. So what I need to do is I need to find a formula for theta that has an x in it. All right, so if you look at what we've got, in terms of your angle theta, you have the opposite side, and you also have the adjacent side. So that lends itself to using tangent, because tangent, remember, is opposite over adjacent. All right, so I'm just going to kind of write this down, what we know. We know that tangent is going to be opposite over adjacent, and we do have both of those sides. So I'm going to plug in, for the opposite, I'm going to plug in x. And for the adjacent, I'm going to plug in a half. Now, remember that in order to simplify, when you are dividing by a fraction, we really can't divide by a fraction. Instead, we multiply by the reciprocal. So having x divided by 1/2, x divided by 1/2 is really the same thing as x multiplied by the reciprocal of 1/2, which would be 2/1. So this is going to be 2 times x is 2x, and we have the 1 in the denominator. So this is going to be equal to 2x. All right, so I'm going to simplify it in that manner. So I now have tangent theta is equal to 2x. And we want the formula to be for theta. So what that means is that we want it to be theta is equal to. And so the best way to have that happen is to transform this equation into an inverse function. And so remember, we're just going to shift the order of the pieces. And so we're going to say that the angle will be equal to tangent inverse of 2x. Right, and this is the part that they're asking us to find. This is the answer to our question. We have an angle equal to tangent inverse of 2x. Okay, so let's move on and look at our next example. All right, so it says express sine of cosine inverse of 2x as an algebraic function of x, assuming that x lies in between -1/2 and +1/2. Okay, so this is similar to the first problems that we worked in this presentation, in that we are going to start working this by dealing with this part inside the parenthesis. So we know that this is basically telling me that cosine of some angle is going to equal 2x. Now, this is not going to be something where I'm going to specifically be able to name an angle, and so I'm going to need to draw a triangle. Remember that on the cosine inverse, let's go back and take a quick look at our chart. On the cosine inverse, we can use quadrant 1 or quadrant 2. Quadrant 1 is for the positives, and quadrant 2 is for the negatives. Okay, so we're going to go ahead and go with quadrant 1 because it appears that 2x is a positive function. We don't see any negatives there. And so I am going to draw a triangle and place it in quadrant 1. And so our angle lies here. We're going to make a triangle out of the initial and the terminal sides. And we're going to substitute in what we know. Now remember that this 2x is over 1 right now. And so we have the adjacent side and the hypotenuse. If we look at our definition for cosine, again, SOHCAHTOA, cosine is adjacent over hypotenuse. So I'm going to fill in what I know. So I know that the adjacent side is 2x and the hypotenuse is 1. Now, let's go ahead and find the missing side. Now, keep in mind that this is a little more complicated because we're not dealing with numbers, but we're dealing with an x, but it's going to work the same way. So we're going to take our 2x, which is one of our legs, and we're going to square it. We're going to add our other leg. Let's call this b. So b squared. And we're going to set it equal to our hypotenuse squared. All right, so solving this, 2x squared, we square the 2, which makes 4, and we square the x, which makes x squared. We square the 1, and we get 1. And remember that we're solving for b. So I'm going to now subtract the 4x squared from both sides. And I have b squared is equal to 1 minus 4x squared. Solving for b means that I'm now going to take the square root of both sides. So b is equal to the square root of 1 minus 4x squared. All right, so let's put that on our triangle, and then we'll continue with our problem. So 1 minus 4x squared underneath the square root for our missing side. Okay, so again, what we have done now is we basically have solved the part that I've circled. Okay, we solved it by drawing a picture. We know that this is equal to an angle. What angle, I can't tell you exactly, but I can tell you that it's angle theta represented in your picture. And then we're going to pull our sine down to finish up the problem. So I basically need to find sine of this angle. So remember that the definition for sine is opposite over hypotenuse. So our opposite side is going to be the square root of 1 minus 4x squared. And our hypotenuse is 1. And so as we simplify this, we don't need to write it over 1. We're going to write as our final answer 1 minus 4x squared.